The main question that you need to ask is that why is this NoSQL? Why ACID is no more relevant? And do recent web applications have any different needs than the previous web applications? And what changed recently? These are some of the questions that you need to ask when you take up any NoSQL databases. So what changed is massive data volumes. Okay, this is the first thing. Okay, there's a huge amount of data. And second thing is extreme query load conditions. Okay, extreme query load, and then the bottleneck is joins, because distributed joins, when the data has to be fetched from multiple slices, or what you call the shred, and then you have to do a join, then it becomes a problem. Okay, and one more feature that is that we missed it here is that schema evolution. Okay, in your traditional RDBMS, the schema is rigid, which means that you do it once and then the schema never changes. Okay, with this new recent applications, there is something called as a flexible schema, which is the schema never gets fixed and it just evolves. And then the database permits you to do this in a much more easier way without troubling. Okay, the applications can be written to leverage this schema flexibility, I mean evolving schema. Okay, so in today's world, it is almost impossible to have a fixed schema for a web scale database, because we are no more following the waterfall model, which also means that we don't design, this is my database, this is how the table is going to look like. I mean, not for all applications, but predominantly lots of web applications these days, social media applications, and lots of new classes of applications falls into this category, where you can't fix your database schema. Okay. So with NoSQL, schema changes can be gradually introduced in the system, unlike your older system, where, say for example, if you have to have Oracle, and if you have to have a flexible schema, then you have to do too many go abouts and then modifying that to accommodate flexible schema. But in NoSQL databases like Cassandra or HBase, this is a part of the system. Okay, it is very simple to have a evolving schema created. Okay, so there are advantages and disadvantages of NoSQL, but predominantly we work on NoSQLs for their advantages, and then we will overcome their limitations, and each database is overcoming their limitations in its own way. The first one is NoSQL databases, no matter what database you are talking about, they are designed for high availability, and they are lower in cost, because most of them are open source, and most of them can be set up using commodity hardware, and they all have a predictable elasticity. Predictable elasticity is the capability that is, you have 10 machines, you can have one scale. Suddenly, if you have 20 machines, the scale can be increased, which was not the case with Oracle or any other databases. They can't scale linearly like what you expect. Okay? They are designed, they have to scale, means that the Oracle has to tell you that this is how you are. It's not like that you assemble some 10, 20 machines and then you can get those features. Okay? So that is the predictable elasticity with this. So on the limitations, most of them had a limitation apart from the Cassandra and MongoDB. So the query language is slowly coming up, but most of them don't have a query capability. Okay, and if you take HBase or any other databases, you don't have what you call as a query. Even in Cassandra, the SQL that you are seeing is only a recent addition, and then it's not very widely accepted. I mean, when you say widely accepted, it's like it's not completely deployed in lots of productions. People are still using only the Swift-based access to the Cassandra. Okay, so the SQL, so the query language is very new for Cassandra, and it is not that heavily proven also. But only in MongoDB the query language is extremely proven, because from the day one they had a query language. Cassandra, they never had the query language, so they had something called as a put and get kind of a functions, very trivial function. The SQL is now overcoming that actually, because going forward, Cassandra, they are promising that SQL will be much more standard, and they'll try to keep the SQL as close to ANSI SQL, so people can directly use Cassandra with just using their SQL knowledge. Okay, that is their goal, and they are progressing on that. So whoever is using Cassandra, you can actually stop learning the other different APIs, and then can actually concentrate more on SQL as well as the Hector-based approach. Okay, because those two things are getting much more popular, and they are also trying to, so the DataStax is also trying to write a JDBC driver similar to what you use Oracle. So you can actually use a JDBC driver and then connect to Cassandra and then can write JDBC calls. So they are working on those concepts, okay, but it's immediately for your projects it may not be applicable, but over the period of time, Cassandra will have those capabilities. Okay, and so eventual consistency is not intuitive programming. Okay, so I'll talk about what it means by eventual consistency. Okay, so in all the RDBMS, consistency is there. Okay, if I write, the data is always, the next read will always have this particular write. Okay, this is eventual consistency model. This is consistency. This is where RDBMS strives. Okay, and all the RDBMS, all the new NoSQL databases have this concept of eventual consistency, which means there is a relaxed consistency model. Okay, so just hold on to this thought process for now, and then I'll talk about what it means by relaxed consistency. Okay, and because of this relaxed consistency, programmers or applications are not very well tuned how to use this relaxed consistency model and what kind of error checking they need to write, how to ensure that the program is correct, how to ensure that the data is correct. All these things are not very trivial to the programmers, and initially it takes a little bit time to get adjusted to this particular way of writing code. And there is absolutely no standardization. What you learn, what you do in Cassandra today may change tomorrow, and nobody can be blamed. That is how the open source community is. Until there is some standardization coming in. What happens with Oracle or any other thing is there is a standard, there is an ANSI SQL. So you write database using Oracle, and then tomorrow you want to move to MySQL. You can easily move it by changing your RDBMS, your database drivers. Because if you standardize on JDBC or standardize on SQL, everything is going to work apart from some custom SQL commands which are very tuned to one particular. But in this world, there is not like that. If you write an application predominantly for Cassandra, it is not very simple to move it to HBase, okay? Unless you take extreme measures from the beginning that you shield your application from the database by writing it in an adapter or a pluggable architecture, it will be very difficult, okay? So people who are attempting to use NoSQL database have to make sure that it is up to them to make sure that their application is shielded from direct databases. So you have to always wrap your database into some interfaces and then use those interfaces in your application, and from your application never make any direct calls to databases. So that whenever there is a change, only the implementation of the interfaces has to be changed as in the plugin, and you can actually work on that. Okay, so that needs to be taken into consideration before any bigger projects are started. That is what I say. Portability might be an issue. Okay, and access control. There is absolutely no access control in most of the NoSQL databases. What essentially means is that in Oracle you have access control. So for example, if Mani is a user is given access to a particular table, he'll only be accessible to the table. But in Cassandra or any other databases, the concepts are not there. It's not that they are not going to have it, but all these softwares had their 1.0 release very recently. Okay, so it will take a lot of time to get all the features that regular RDBMS is having in these databases over a period of time. Okay. You need to know what it means by CAP theorem. Okay, so CAP theorem essentially means, okay, let's put the definition, official definition. Okay, what it essentially means is that in a distributed system, any distributed systems can satisfy only two of these properties, either consistency or availability, are tolerant to partition. That is what general concept is. But let's debug the concept. Okay, so a highly scalable system. Okay, very big systems. If you take any big system, okay, that means if you have to store huge amount of data, as we talked, we can do that system only by partitioning. Okay, so you cannot have a big system without having partition. Okay, so the fundamental understanding is wrong, which means that it's not about that. Okay, it's not about either two of them you can have it. Okay, without partitioning you cannot build any big system. Okay, partition is mandatory.